Hello everyone, hope you are all doing well. In this video I am going to talk about heap data structure that we will be using in our later videos for understanding heap sort. And in this video I will be talking about introduction of heap. So what is heap? It is a data structure. And what type of data structure it is? It is actually a complete binary tree which follows heap order property. So there are two important things here, that it is a complete binary tree and it follows heap order tree. Any complete binary tree which follows heap order property, that will be a heap data structure. So first of all we must know what is a complete binary tree. For that we must know what is a binary tree. So you must be knowing that binary tree is a tree data structure in which all the nodes contain at most two child nodes. So complete binary tree, if we talk about complete binary tree, complete binary tree, in short it is also called CBT. It is a tree, that is binary tree. It is a binary tree in which all levels are completely filled. Now what do I mean by this? All levels are completely filled. So now let us see. And there is a I want to add something here, except last level, that is last level can be incomplete. So if I make a binary tree like this, here this node is having two children, this node also having two children, this node also having two children, and this is having two children, this is having only one children. So level 0 must have 2 to the power 0 nodes, level 1 must have 2 to the power 1 nodes, and level 2 must have 2 to the power 2 nodes. 2 to the power 0, that means 1 node, 2 to the power 1, that means 2 nodes, and 2 to the power 2, that is 4 nodes. And last node can contain 2 to the power 3, that is 8 elements, but it can remain empty in a case of complete binary tree. So it is a complete binary tree, and there is one more property that I will write here. Last label must be filled from left to right. Now what do I mean by that? It means that if I place a node here, then it will not remain a complete binary tree. Because of this property, last label must be filled from left to right. Means if there is a node here, then all the nodes here must be filled. Means right node of this node and left child and right child of this node must be filled, then only this node can come here. So it is not a complete binary tree if I add this node. If I remove this node, it will be a complete binary tree. Now we were on heap. First of all, it is a complete binary tree, heap is a complete binary tree. We have now understood what is a complete binary tree. Now we'll talk about this heap order property, and before talking about this heap order property, first of all we must know the types of heap. So we have two types of heap, min heap and max heap. And this heap order property depends upon the type of heap. First of all, let's talk about this mean heap. So mean heap tells that all the nodes of a tree must be less than its children nodes. All of its children nodes means if I am having a tree here like this, then this node must be smaller than all of its children. This node must be smaller than this node and this node, and this node must be smaller than this node and this node. And as there are no children for this node and this node, so we will not see this property for all this node which do not have any children. So the node which are having children, that node must be smaller than all the keys of its children. So for example, if I take a tree here, 1 having node 2 and 3, 2 is having children as 4 and 5, and 3 are having children 6 and 7. So if we see min heap property here, that is 1 is smaller than 2 and 3, and here node 2 is also smaller than 4 and 5, 3 is also smaller than 6 and 7, and rest of the nodes do not have any children. So this follows min heap property for all the nodes, so it is a min heap. Similarly, if we want to talk about max heap, the this condition is reverse, that is of this must be, each node must be larger than all of its children nodes. So if I draw a max heap here, let's say root node is 100, it's having child node as 60 and 50, and 60 is having childs as 10, 20, 30, 35. So it is the example of max heap, as 100 is greater than all of its nodes, that is 60 and 50. 60 is also greater than all of its children, that is 10 and 20, and 50 is also greater than all of its children, that is 30 and 35. So it is a max heap. Now hope you understand the introduction part of this heap, that is it is a complete binary tree and it follows heap order property. In the next upcoming videos, we are going to talk about insertion and deletion from this heap data structure. Thank you.